Hello, welcome back to Fundamentals of Graphing and Slope. This is part 2. I don't like the videos to get too long. 15 to 20 minutes is really my goal, and when it gets into the more than 20, I decide it's time for a new part. So here's the new part. Let's talk about some definitions. Linear equations. An equation is linear if it has a constant rate of change, so the slope is constant. That is, for every unit change in the input, the output has a constant amount of change. And we'll look at that in detail and what I mean by that. There are many different ways we could write the equation of a line, and the slope-intercept form of a line looks like this. Y equals mx plus b, the m being the slope, the b being the intercept. Mathematicians are very descriptive in how we name things, and it's really because it needs to tell us exactly what it is. Slope-intercept form. There's enough going on in our brains at one time that this keeps the train on the right tracks. A definition of slope. Slope is the increase or decrease in the output variable for a unit change in the input variable. In the slope-intercept form of a line, slope is represented by m. Remember, that was also y2 minus y1 divided by x2 minus x1. The vertical intercept is the point where the line crosses the vertical axis. Frequently we call this the y-intercept, but vertical intercept is really a better name for it because we don't always use x and y in our problems. In the slope-intercept form of a line, the vertical intercept is a point, so it is 0, b. It's not just b, it's the point 0, b. It's more frequently called the y-intercept, but we're going to use vertical intercept as much as I can remember to do that. So in these examples, we're going to determine the slope and the y-intercept, and then we're going to sketch using the slope and y-intercept. So if we're going to sketch a graph, I'm going to lay down some axes here. I don't label them until I find out what's going on. So first of all, my slope is 3, but remember, slope is always a fraction. And so if you have a number that does not seem to have a denominator, it always has a denominator of 1. I can't write a 3. Oh my goodness. Let me stop talking and see if I can focus on writing a 3. There we go. We can always put a denominator of 1 because this tells us we'll rise 3 and we will run 1. All right, so that's exactly what our slope tells us. Our b value tells us the point on the graph where we are starting. So at 0, -7, let's go back to black here. Let's go 1, 2, 3, 4, 5, 6, 7. And about the same distance, 1, 2, 3, 4, 5, 6, 7. If I needed to, I could make some lines back here and up here as well. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I put at least one number in each direction just to let you, my viewer, know the scale on the graph, and that's something that you should do as well. So 0, -7 is where we're going to start. That's right there. We'll put our first point. Let's actually make that in blue. And then we're going to use our slope. From this point, we're going to go up 3. So that's 1, 2, 3. And then go to the right 1. And that's our new point. And we could do it again. 1, 2, 3 to the right 1. That's our new point. And if we keep doing this, up 3 to the right 1, we can find our equation. Not our equation, we already have our equation. We could find our line that we're graphing. All right, there we go. I should have made that in black. All right, let's try this again. So here in number 2, we see m equals a -3/4. We see that our b is 1/2. So we're going to start at the point 0, 1/2. Let's put up a graph here. 0, 1/2, 1, 2, 3, 1, 2, 3. Go 4 in each direction. Maybe I'll make that a -4. There we go. So we start with our y-intercept at 0, 1/2. All right. Oh, that's not right. 0, 1/2 is right there. So I am going to see if I can erase just that point. Of course not. There we go. All right, so we have our point 0, 1/2. From there, we want to go down 3. This negative always tells us up or down. And we'll always go right in the denominator. So we'll go from here down 3. So that's 1, 2, 3. And we'll go to the right 4. 1, 2, 3, 4. And there's our point. Once we have our y-intercept and we use our slope to find a second point, it only takes 2 points to draw a line. And there we have our line, -3 over 4. Fantastic. Let's do one more. Oh, we're going to do a couple more of this type. If we have y equals 5, first of all, if we want to write it in this form, we could write it as y equals 0x plus 5, because 0x is how many x's are showing in the original equation. My slope is 0. My b value of 5 tells me I'll have a point at 0, 5. So let's draw this graph. One, 2, 3, 4, 5. Now my slope of 0 is going to tell me that I go, let me see, 0 over 1 is still good. So I go up 0. I'll go right 1. So I go up not at all. I'll go right 1. And yeah, you're right. I should put some labels down here. So what are we going to do? Well, 2 points to determine a line. This turns out to be, if you could draw it correctly, a nice horizontal line at y equals 5. If the slope is 0, there's no tilt to it whatsoever. It's a horizontal line. All right, good job, way to go. Yep, that's all this part is. That's good. All right, just recognizing some slopes, drawing graphs. M equals 3/4. That is up 3 and to the right 4. But up 3 and right 4 from where? Well, our b value of -6 gives us a point of 0, -6. So let's draw our graph. 0, -6. Let's start with our b value, 0, -6. From there, we're going to go up 3 units. So that's 1, 2, 3. But we don't make a point there. We have to go right 4 as well. 1, 2, 3, 4. That's where we make our point. So from the y-intercept, we use the slope to go up 3, right 4. And now we can draw our graph. Do your best to make this a straight line. On the computer, I can't really use a ruler but you can if you want to, if it's that important to you, or you could use the line tool if you happen to be using WebAssign, and I believe my math lab also has line tools. So if you're using online homework, this is still possible. In number 5, our slope is -2. Remember, slope is always a ratio, so I'll always want to write it as a fraction. Me personally, I always give the negative to the numerator, because that way it tells me up if it's positive, it tells me down if it's negative, and I always go to the right. All right, so down 2 to the right 1. My b value is 7, so I am going to start at the point 0, 7. We could go all sorts of big on this one. Looks like I don't have to go too far on my x-axis. but let me go till 5 at least. My point 0, -7. And from there, from my y-intercept, I'm going to go down 2, 1, 2, and I'm going to go to the right 1. Down 2, right 1, and then we'll draw the line that connects these 2 points. If you ever miss a point as you're drawing the graph, you make it bigger and it's all better. All right, so, oh, there's more. There's absolutely more. Sketching the graph given slope-intercept form, pretty straightforward if you could identify the slope and the y-intercept. All right, now let's look at real-life situations. These are called models. Find the slope of the model and explain its meaning in the situation. So let's use red for slope again. The pressure inside a vacuum chamber can be represented by P equals 35 minus 0.07 S, where P is the pressure in pounds per square inch, PSI. Think tire pressure, basketball pressure, soccer ball pressure, volleyball. Yeah, I could keep going. Not baseballs, though. They don't have pressure. Of the PSI of the vacuum chamber after being pumped down for S seconds. All right, so what's changing? The slope is how it's changing. And so my slope will be negative 0.07. Not the S, just the number in front of the variable portion of our model. So what does this mean? This means that decreasing because of the negative, 0.07. Remember that slope is change in y over change in x. That's a delta. Delta is the Greek symbol for change. And so slope units will be the units of y. The output, P, is the pounds per square inch. The units of x in general, the input, is seconds. So it's decreasing by 0.07 psi per second. What is the pressure is? So that's what it means by explain its meaning in the situation. It's easy to identify the m. It's the number in front of the variable in a linear equation. But in order to find the units, always remember it's output over input. Still alphabetical, right? Top, bottom, numerator, denominator, output, input, I comes before O. Yep, I just did A, E, I, O, U to make sure I was right. And we get this decreasing value. All right, so that's our answer. Let's make some tacos here in this next one. The cost for making tacos at a local street stand can be represented by C equals 0.55 T plus $140. C is the cost in dollars to make tacos at the local street stand where T tacos are made. So we know our slope is the value in front of the variable, right? It's the cost per taco. So, and I just told you what the answer is. So because it's a positive cost per taco, right? Cost per taco is 0.55 to make. And we'll just throw up a dollar sign because C is in dollars. We don't want to assume that this is euros or pesos or yen or drachma. Although those aren't used anymore. Just put the dollar sign. Make sure you use units appropriately. All right, gonna make me hungry here. Let's now talk about some pizza. Let C equals 4.5 P plus 1,200 be the total cost in dollars to produce P pizzas a day at a local pizzeria. Our slope is 4.5. Well, what does that mean here? It means that it is $4.50 per pizza to produce. So when you buy a pizza for $9, they're making a $4.50 profit. Kinda. after they overcome that $1,200 fixed cost. But it costs the pizzeria $4.50 per pizza to produce. Last one, D equals 0.28t plus 5.59. The coefficient of the variable is always the slope, never the variable, just the coefficient, the number in front. D is the percentage of adults. I'm going to write this here, D over T, percentage of adults aged 18 years old or over in the United States that have been diagnosed with diabetes, and T is in years. It's actually years since 2000. So the rate of diagnosis is increasing because it's positive at 0.28% per year. I don't know how I could possibly misspell the word year, but yet I did. It is math, not spelling, but you know, we should do it correctly when we notice. A rate of diagnosis is increasing. Diagnosis is increasing at 0.28% per year. If you want to know why I erased that rate of, you should take calculus. I'll tell you all about it. All right, check out some of my calculus videos for calculus type information. All right, so all about slope, graphing, slope. You got this. You could do this. This is part 2 of fundamentals in graphing and slope. Thanks for listening.